Yes, definitely.
Thank you very much.
Okay, thank you. And it's time for calling Valerio Mazzoni with a paper titled Biotremology as a New Tool of Ecoacoustics. Valerio, is your...
Good morning, everybody. Good morning, Almo. It's really a pleasure for me to be here with you. I'm not really a bioacoustic guy, but I work with biotremology. And I'm going to talk about this and see if we come out with some new ideas, some collaboration and proposal to work together. Can you see the screen? And now I start. Is okay?
Yes.
Okay, then I start. So biotremology is something that in the past has been considered for a long time like the little sister of bioacoustics, and only in 2014, 16, sorry, has been defined as a separate discipline. And together with bioacoustics, they belong to the discipline called biosilology, that is a part of biocommunication by means of mechanical waves. And indeed, there are differences important with bioacoustics, and we see some example. But basically, now biotremology is going rather well, is developing, it is spreading in different parts of the world. And as you can see, there are the first books, there is official logo and channels of Facebook, YouTube, and we have also a World Symposium that is every other year. And unfortunately, of course, last year, because of the pandemic, this one was not done, but next will be done in 2022 in Slovenia. So biotremology is something that is spreading, and as you can see, there are many animals that use vibrations as an important communication channel. And we talk about fish, reptiles, birds, amphibians, mammals. And you see in the picture, Caitlin Connell, that she is one of the most important experts in communication of elephants. Of course, arthropods. I'm an entomologist personally, so I'm working with insects. And however, also spiders and scorpions are really important for biotremology. A couple of examples, the elephants, they can transmit information, as you can see from the figure here, for many kilometers, and there are different types of information. The first that come to my mind is alarm, to transmit information of alarm to other conspecifics in case of presence of predators. And there are specific organs at the base of the foot, this fatty cation, that are selected to favor the reception of this kind of vibrations. Examples that are interspecifics involve, again, in this case, elephants, but it could be another herbivore, and ants on acacia tree. What happens in case of a predator is a grazer? In this case, the elephant go near the acacia to feed, and this feeding behavior creates specific vibrations, and this triggers the alarm of the ants that then go chasing, I can say, the elephants by biting the trunk and so saving the acacia from damage. So, but these are two examples. There are many examples, and so the biotremology is not something that is a curiosity. And if we see this insect phylogeny, you see that if you talk about airborne sound communication, well, we have very few taxa that are really using a lot airborne sounds. Of course, we have the Orthoptera, that is the classic, but we find other examples. But when we go for vibrational communication, well, we can say that insects are really vibrational animals, okay? And you can find it in basically all taxa. And there are more than 200,000 species that we know they use for sure vibrational communication. So the point is that we can imagine a very important environmental network of communication by means of vibrations. And this is really similar to what we find in acoustic, but as you can see, we have the sender, we have receivers, we have unintended receivers and intended receivers, eavesdroppers, and antagonists. So it's a very complex world. And it's very interesting to start exploring in deep and see what are the ecological implications in this. What was the constraints up to now? Well, first of all, biotremology until a few years ago was done in the lab. You can imagine working in a sound insulated on an anti-vibrational table using very sophisticated lasers and no background noise. So there were sort of problems that were associated with excluding noise, and you need to make a characterization in a very silent environment and protected from external noise. And the main problem is that in this case, you really miss the natural context, you miss the social interaction. So it's time for biotremology to move to the next step. And there are the first studies, there are other presentations, the one of Rocksturm on Friday, and they start talking about vibroscape. So what is a vibroscape? Well, of course, it's like a soundscape, but instead on the air, on the environment, we are talking about vibrations. So we are talking about a small portion of plants or bushes or trees. It's a sort of investigation on a specific target. So doing a landscape approach is more difficult, but technology is coming to help. And every year we are developing, detecting, discovering new solutions that are helping us to improve this aspect. What are the main constraints? You can see here in the list. The field equipment can be very heavy. Power supply, sometimes to move a laser vibrometer, you need a lot of energy. And of course, a normal problem of data storages, analysis, noise to be controlled, weather conditions, because you need somebody to work with the lasers. And another big problem that we have not a library. So there are few species that we know the communication, the signals that they use. So going in an environment like this one in the picture, you have probably 90% of, or even more of signals that you can't say what is the source. And it is a big problem. So basically, I made 3 questions during my work. And one is that is it possible to use techniques of biotremology to monitor a habitat? Is it possible to monitor the occurrence of a few target species at least? Because we can imagine that we can search for something in a certain environment. Another question is, well, is this a reliable technique? The information that we collect is reliable, and let's see. So the point is that we studied in these preliminary experiments a simplified model that is an organic vineyard. So what are the advantages? Well, I can expect to have 1 or 2 dominant species that are the pest, and the others that are more or less occasional. And there is only 1 target plant. Yes, in a wide vegetation environment with the weeds and whatever you want, but we're recording from 1 target plant. So we're trying to reduce the scenario in order to simplify this approach. This is the map of the vineyard that we analyzed. You see that around there are also woods, other vineyards, apples, and an uncultivated area with the ditch, with the frogs and other things. And the idea was to say, okay, let's analyze the vibrotypes, how many types of vibrations we can find, and the pattern of the day of vibrational signaling activity that we call VSA, and the daily pattern of the main target species. In this case, is a grapevine pest that is specialized on grapevine, and another generalist pest, so Scaphoideus, titanus, and Marmorated. Of course, you see the setup, we need batteries, laser, a beach umbrella, because otherwise it's a problem from the instrument. And of course, Iman, that was the PhD that did this study, and working 7 hours a day on 24 different sites in the vineyard for a couple of months. So trying to collect as many data as we can. What we see, for instance, is first of all, we have during the day, this is data from on an average of the single day, most of the activity is concentrated in the late afternoon. We didn't go into the night for the moment, we will do in future. While, for instance, there is a big break of activity in the hottest part of the day. And as a vibrotypes, you see is a bit similar, although there is more species, but with the low activity in the morning, and the rest is more or less similar to the other trend. Doing a correspondence analysis, we found elements that indicate what is a zero, no activity. High wind and low humidity and high temperature means no activity. Well, for the rest, there are many other combinations, less clear. However, in general, high humidity, medium low temperature, and low wind, they are triggering more activity. And these are the graphs about the number of vibrotypes that are corresponding to the first graph that we saw. That is the temperature and the wind velocity. You see that highest point of temperature, wind velocity, and you see a significant effect. In fact, vibrotypes number, temperature, wind velocity, they are the significant effects on the vibrational activity. And we found also data about possible thresholds. In fact, temperature over 30 degrees, they really abate all the activity. And also wind velocity more than 4.2 meters per second. This is also abating the activity. And these are parameters important in the future if we want to set up other experiments. We know which days we need to avoid. We get this information from target species now. You see, this is a Oleomorphalis, a pentatomic species. It's very active in the morning. It's not part of the, there is some peak in the afternoon, in the late afternoon, but this is not the species causing the high afternoon activity. Which one? The species that makes so, it's a Scaphoideus. Scaphoideus titanus activity is exclusively, let's say, nocturnal or late afternoon. And in this case, we wanted to make an assessment and say, okay, can we use a Scaphoideus for an assessment of this, to understand if this method is valid? And we did an experiment in semi-field conditions on different plants where we had 6 males for each cage, and recording vibrational signals basically with the same scheme that we did in the field. And what we found, measuring vibrational signal activity, what we found, this is the field recordings, this is semi-field recordings, and we found exact correspondence. This makes us thinking that our field recordings are rather reliable. Of course, we have some loss of information. You see that is starting a bit earlier, 1 hour earlier, the activity in the semi-field. There is some small activity, but however, it's rather reliable. It's not far away from what are our observation. And to this, I want to come to the conclusions, because I guess that it would be nice to have more time for discussion considering this topic. And these were the 3 original questions. Possible to use techniques of biotremology to monitor an habitat? Yes. Despite background noise and other restraints, we did it. We found different vibrotypes. We had a nice curve, and however, we know what are the limits, but we can improve, and the technology is helping a lot. And now we are also using some interesting accelerometers, for instance, that are much easier to handle. And the other point is it's possible to monitor a few targets, sure. And if we know the library, if we know the signals, it's possible to target some species, especially when you work in an agroecosystem where you know that we target possible targets. Is this information reliable? We think so. At least we tried only Scaphoideus, of course. But the point is that we found a very good correspondence between the field trials and the semi-field trials. I conclude by thanking some some colleagues that help us in the analyzing, using software, and also in the field recordings. And I hope that you will see biotremology in different eyes in the future. Thank you.
Thank you very much, Valerio. Very interesting speech, and this new perspective of working with a new devices. Very sophisticated, very expensive, I can imagine. No, are expensive these devices? Or?
The laser is about 20,000, but the point is not the laser. You need acquisition devices, you need software dedicated. But lately we are using solutions much cheaper. I mean, if you have a budget of 5,000, you can do a lot of things.
Okay. And what is I lost something. The range, the spatial range on which you are.
The point is that we have some meters of range. So we need to have many recording points. So every day we stayed, for instance, 7 hours in one point that cover one plant, you can imagine. And the day after we move, and then we move in order to have a coverage of the environment and putting together the information. It's time consuming.
Yeah, but the machine is fixed. You cannot. Yeah. Oh, it's fixed.
You can move it if you want, but normally you choose a point.
Create confusion.
But now with accelerometers, we can use more instruments together, and we are finding very good results. But we are still doing the experimentation, so I can't present the results yet.
Yes, I don't know see other questions, but
there are some questions I see. I don't know which one is the first because I see a series of questions. I don't know if Giuseppa is the first or there are before others. I think no, Giuseppa. Why you don't have data during the night? Because this was a PhD student and I couldn't force her to go in the night after staying 7-8 hours in the day. This is a preliminary work. In the future, we do also in the night. But this was just to understand if what we do is feasible. And we are very optimistic. So in the future, we go also in the night. Then I see a question of Rock. Hi, Valerio. What part of the whole vibration activity was occupied by Leafhopper, Scaphoideus, and Marmorated Stinkbug? I don't know if you mean as a quantitative. As a quantitative, the night part, the last part was basically 90% of Scaphoideus. So, but we are in the vineyard. I was expecting this. And if I just move to the next plant, probably I find something totally different. And then I see Yan Yi Lu, question for Valerio, is there vibrational partitioning? I don't know exactly this term, if you can explain to me, Almo.
Yeah, what means that if you can see differences in sound, the vibration can be differentiated.
Yeah. Okay, no, you can understand that every species is a species-specific sounds like those that you see for crickets or other animals. If you have your library, you can recognize everything. The problem, as I say, we have not a library because there are very few people doing this job. And it takes time to make a good library reliable.
Okay.
I see another one. I don't know if I have time. You can tell me if I...
There is another question.
From Alice.
Yes. Okay. Well,
can I?
Yes, please.
Okay. Do we think vibromechanical sampling is logarithmic like hearing? I am wondering about the relevance of Mel scaling in ecoacoustics in general and also biotremology. Probably it is. I'm not expert in this, but there are many parallelisms. And until a few years ago, biotremology was considered as a part of bioacoustics. So the main difference is the means of the media. But many other things are very similar. So I guess that the sense, we should ask somebody that is studying also neurophysiology. They will tell us interesting information.
Okay. Okay. Thank you, Valerio. And now, before to pass to David Monacchi, the next speaker,